So this is video 5.3E as in echo, and I'm just going to take some of the exercises from the book and do them with you just so that you're a little bit more familiar with what's going on. This is number 21 in exercise 5.3, page 468. So let's go ahead and write this matrix form. Okay, so again, we want to get my major diagonal as 1s, and that is 0, and that is 0. So one of the things that we want to do, and this is kind of a little bit of an extra tip here, is I want to really try to make some of these numbers multiples of others. So if I multiplied this bottom row here, if I multiplied the bottom row by 3, that would make this a 6, this a -9, and this a -27. So if I made this 2 a 6, that would be a multiple of 3. And that's always going to be handy, is if I can somehow make one of the columns multiple of the other one, then it's a lot easier to make everything work out, because I'm trying to change this to a 1, and if I can make this 2 a multiple of 3, it will be easier. So let's go ahead and do that. So let's leave the top row alone, and I'm going to multiply the bottom by a 3. So then this will change to a 6, a -9, and a -27. Okay, so now what I can do is I can multiply row 1 by a -2, so I'm just going to put that like that, by a -2, and see what's going to happen. I multiply this by a -2, that makes that a -6. I add that to this 6, makes this 6 here turn into a 0. So that's why I did it by the multiple here, so then I could do this next step and change this one to a 0. So I'm going to multiply row 1 by -2 and add it to row 2. So again, I'm going to multiply it by -2, but I'm not going to show it here. I'm just going to leave it the way it is. And what I'm going to do is take -2 times 3 and get -6, add 6, and get 0. I'm going to take -2, multiply it by 2, get -4, add 9, get -13. I'm going to take -2 times 6 and get -12, add -27, and get -39. Okay, so all that, and it got this number right here to be a 0. Okay, so now let's see. It'd be nice if this were a 1. So if I divide this whole row by -13, because this is a multiple of 13, I'm going to do that, and it'll work for me. So let's see if we can get some of this out of the way. So move that up there. Okay, so we're going to multiply this row here, or divide this row here by 13, -13, and -13. So my top row is going to stay the same. My bottom row is going to turn to that. Okay, so we're getting there. We just changed the our bottom row has a 0 and a 1 there, so that's good. So let's kind of pile all that up there so we can continue on there. Okay, so now we have that. Let's see. If I multiply row 2 by -2, only because I want to get this 2 here to be a 0. So it's always nice if there's a 1 in the same column here, because then I can multiply it by its opposite. This is opposite, and that'll change to a -2 plus 2, which will make that a 0. So whenever you want to make a space 0, an element 0, then I just look and see if there's a 1 above or below it and multiply that row, in this case here, by its opposite, and then that'll turn that into a 0. So again, I'm going to write my bottom number because that's not going to change, and my top number will change because I'm going to multiply negative 2 times 0 is 0 plus 3, so that will stay a 3. And then I'm going to multiply negative 2 times 1 and get negative 2 plus 2, so that's going to change that to a 0. Then I'm going to take negative 2 times 3 is negative 6 plus 6. Oh, that also gives me a 0, so I'll put that there. Okay, so I'm slowly but surely making these changes. Now the only other change I have is that has to be a 1. Well, it's really easy to change a number to a 1 because I just divide all of it by itself. And then that gives me 1, 0, 0, line, 0, 1, 3. Okay, and in this particular problem, this is what, number 21, it's asking us to use the Gaussian or the Gaussian-Jordan elimination. If I just do the Gaussian, I'm done there, and I can find out that and according to this row, my x is going to be equal to 0, and my y is going to be equal to 3. So I'm happy with that, and I'm done then. Okay, so this one is number 29. So we've got 3 rows and 3 columns. It's going to take a little bit of work to get there. So let's go ahead and write it as a matrix. Negative 1, negative 3, 1, 8, 1, negative 1, 5, 2, 1, 2, 5. Okay, so it looks like we have a 1 in a nice place there in our major diagonal, because that's all going to be 1s. So that's kind of nice to have that there. So let's do the Gauss-Jordan elimination in this one and make them all 0s except for the major diagonal there. We'll make that 1s. So gosh, I think one of the things I would do is I'm going to switch this row, and it doesn't really matter, you don't have to. I'm going to switch this row with this row so that my multiples of 2 are below. So if I do that, I would get 2, 1, 2, 5, 8, 1, negative 1, 5, and then 4, negative 1, negative 3, and 1. Okay, so I just switched them, and it isn't a have to do, but it's just kind of nice to keep my multiples, my smallest number up here, and then the next ones are multiples there. It just kind of looks better, I guess. So next thing I'm going to do is, and you don't have to do these in this order. I mean, it doesn't matter what order you do them in as long as you do the math correctly. So first thing we're going to do is we're going to multiply this first row by a negative 4, because we're going to try to make that 8 a 0. Okay, so we're going to leave my 2, 1, 2, 5 there because we're not changing it. And my 4, negative 1, negative 3, and 1, we're not changing it. We're just changing the middle row. So, negative 4 times 2 is negative 8 plus 8 is 0. Then I've got negative 4 times 1 is negative 4 plus 1 is going to be negative 3. And then I'm going to take negative 4 times 2 is negative 8 plus negative 1 is going to be negative 9. Then I'm going to take negative 4 times 5 is negative 20 plus 5 is going to be negative 15. Okay, so all that work just to get my 8 turned into a 0 here. Okay, so what am I going to do now? I'm going to look at row 1 and multiply that by a negative 2 in order to get rid of this 4, in order to make that 4 a 0. So let me move everything up here so we can do that. Okay, so here we go. Negative 2 times 2 is negative 4. Well, let's go ahead and write the matrix first. First two rows are not going to be changing. We're only changing the third row. So 2, 1, 2, 5, 0, negative 3, negative 9, negative 15. And then the third row is the one we're going to change here. So negative 2 times 2 is negative 4 plus 4. Let's do this in green. It's going to give me a 0. Negative 2 times 1 is negative 2 plus negative 1 is going to give me a negative 3. Then I'm going to take negative 2 times 2 is negative 4 plus negative 3 is going to be a negative 7. Then a negative 2 times 5 is negative 10 plus 1 is negative 9. Okay, so still cruising along here. So we're slowly but surely getting things switched around. So we have a 0, 0, and a 1 there, a 2, a negative 3, and a negative 7 there. So let's keep going. If we were to multiply row 2 by a negative 1, then what happens here? This 3 here then will turn into a 0 because negative 1 times negative 3 is a positive 3 plus negative 3. That'll turn that into a 0. And that's what we want to do here. So let's go ahead and do that. So I went ahead and wrote the first two rows as is because they're not changing. But remember, I am multiplying this second row by negative 1 so that I can add it to the third row. So when I do that, I get negative 1 times 0 is 0 plus 0, so that's going to stay a 0. Then I'm going to take, let's put the negative 1 up here, make it easier. This is where I multiplied the negative 1, not down here. Okay, so negative 1 times negative 3 is 3. 3 plus negative 3 gives me a 0. Then I've got a negative 1 times negative 9 is positive 9 plus 7 is going to give me a 2. And then finally, negative 1 times negative 15 is positive 15 plus a negative 9 is going to give me a 6. Okay, so again, we're still getting there, slowly but surely, but we are getting there. Okay, so that gives me that. Alright, so let's see here. At this point in the game, I think it might be good to take row 2. And if we divide row 2 by a negative 3, that'll pop that into being a 1 here. Plus, these two are both multiples of 3, so that'll make things good. So let's go ahead and go 2, 1, 2, 5, because that's not changing at all. And the bottom is not changing either. And then the middle row, if we divide by negative 3, we get 0 divided by negative 3 is 0. Negative 3 divided by negative 3 is 1. Negative 3 divided by negative 9 divided by negative 3 is 3. And negative 15 divided by negative 3 is 5. Okay, so that was kind of short and sweet and not too bad. So again, we're going to continue moving stuff out of the way and just looking at our new matrix here and see how we can get to the next one. So let's see here. If we take row 2 and multiply it by -1. What will happen is this 1 will change to a -1, and I can add it to that, and this will become a 0 then. So I'm going to write my bottom one as being left alone, and my middle one is going to also be left alone, and my top one is the one that's going to change. So -1 times 0 is 0, plus 2 is going to give me a 2. -1 times 1 is -1 plus 1. It's going to give me a 0. -1 times 3 is -3. Plus 2 is going to give me a -1. And then I've got -1 times 5 is -5 plus 5 gives me a 0. Alright, so you notice we're only changing one little thing at a time, and that's what's so time consuming about these. So let's see, let's multiply row 3 by 1/2, or I'm sorry, divide it by 2 or multiply it by 1/2. It's the same thing, because we're going to try to get that to be a 1. So we'll divide those by 2. So we get 2, 0, -1, 0, 0, 1, 3, 5, 0, 0, 1, 3. Okay, so still looking good. So that's easy to do when we want to change them to ones. And let's see, next step. We have a nice little thing here because, see, we changed this to a 1 and this is a negative. So if we add this row to this row, this row to this row, this will turn into a 0 here, because 1 and -1 is going to be 0. So that's what's nice when you have the same number but they're opposite in signs. You don't have to do any multiplying a row by a certain one of the numbers opposite, one of the rows opposites here. So I'm just going to add that second row, or third row, to the second row. It helps put the right number there. And that would be a 0. And then that's going to be a 3 plus 0 is 3. And then this is going to stay the same. And this is going to stay the same. Okay, so that's our next step, is we got that turned into a 0. Let's see, if we look at row 3 and we multiply that by, let's get stuff moved around again. We look at row 3 and we're trying to get rid of this, right? So we've got a 1 there, so we're going to look at row 3 and we're going to multiply row 3 by a -3, so that when we add it to row 2, this is going to turn into a 0. -3 plus 3 is going to turn into a 0. So matrix, write everything the same. That's not going to change. 2, 0, 0, 3. And the bottom is not changing either. But 3 times 0 plus 0 is 0. -3 times 0 is 0 plus 1 is 1. -3 times 1 is -3 plus 3 is 0. Alright, so we're getting there. And -3 times 3 is -9 plus 5, and this will change to a -4. Okay, so the last thing we have to do is get rid of this 2 right here. So we're going to take that 2, we're going to divide the whole row by 2, and that will change that to a 1. So I'm going to do that over here to the left. 2 over 2 is 1, 0, 0, 3 over 2, 0, 1, 0, -4, and notice the Gaussian-Jordan way of doing this. Everything changed to zeros or ones over here. So that makes life good because this is the x, this is the y, and this is the z. So x is 3/2, y is -4, and z is 3. And you're done after a long and arduous journey. So that's just a couple more examples to help you get moving here on 5.3.